in this session, you will learn how to generate the pump characteristic curve, head and flow rate data, and additionally, you will find out how to report shutoff pressure, as well as reporting the discharge pressure for a specific flow rate. So let's consider the pump data are actually arranged like this. So once you specify the flow and head data, you can generate the pump data curve. Just follow me step by step. So as you notice, the pump curve generated, as you know, as we increase the flow rate, the head that the pump can correspond to will decrease, right? So now I wanna specify, for example, let's say we have 50 cubic meter per hour as the flow rate, and I wanna find the differential head that this pump can produce, right? And type equals and write the forecast function, open the bracket, and the first array is the flow rate that you want to find its differential head, that it can correspond to. And the second array is the y-axis, which is the head. And the third argument would be the flow rate. Close the bracket and hit enter, right? As you can see, for this specific flow rate, which we have 50 cubic meter per hour, its differential that this pump can produce is 554 meter, right? We have 50 cubic meter hour, and the head that it can produce is 460 meter. This difference between the calculated value by the Excel and the data that the pump can generate, that can produce, is just because we used this simplified formula as the forecast. So just accept this simplified correlation for now. However, you can find you can extrapolate the data exactly. I don't want to get into details and make the discussion unnecessary. Like, so let's consider we have water, which its a specific gravity is 1. Let's say our suction pressure is, for example, is 2 bar gauge, and I want to now find its discharge pressure, which is the suction pressure plus rho gh, right? And the rho, the density is the specific gravity times 1000, which is the density of water at the standard condition, times 9.81, which is the acceleration due to the gravity, times the head that the pump can produce, right, can generate, right, over 10 to the power of 5 to convert the Pascal into bar. As you notice, the Excel will generate, will calculate the discharge pressure, for example, for this flow rate. So now you can change the flow rate. So let's consider we have 100 flow rate, and its differential that it can produce is about 400 meter, and the discharge pressure will also change as well. You can either change the suction pressure or a specific gravity of the flow rate that it can pass through this pump, or whatever you want to use. And now I want to find the discharge pressure where we have 0 flow rate, which means the shutoff pressure of the pump, right? And when we have shutoff pressure, it means that the flow rate within this pump is 0. And as you can see, it calculate the discharge pressure, or it can find the shutoff pressure for this example that we consider. We have water with the suction pressure of 2 bar gauge. You can change the specific gravity. Let's say we have actually 0.8, which is a specific gravity of gas oil. That its shutoff pressure being changed accordingly. So if you have any question about this part, you can ask within the description below.